Projectile motion. Now, when you're talking about projectile motion, it is motion of an object that has been thrown. Such an object that you thrown is called a projectile. Imagine you throw a stone, it is going to go up and then it will drop like that. So there are different forms of projectiles. There is such a projectile where you throw something, it goes and comes back to the same point that you threw. That is the first type of projectile. There is another one. You might be on a building like that. You are going to throw a stone. It is going to go and then reach the very bottom. That is another projectile. And then there is another one where you get to throw something at a level. It goes and then it's going to climb a certain building. That's another type of projectile. So all these types we need to be familiar with them. And the first one we're going to talk about is this same one. So we are going to derive some equations which are used on these projectiles. So a projectile is simply an object that has been thrown. When you throw something straight up, or not say projectile really, that is just free fall. It is subjected under free fall. So a projectile has got both x component and the y component. You've thrown it at an angle. Okay, now let's get started. Here we have a line of motion. Then I'm going to throw a stone from this point up to reach the maximum point, then it's coming back. Now if you look at this projectile like this, there is the angle of pressure which you thrown, that is theta. And then when you throw something, it has got a velocity. So we're going to call that as the initial velocity. Let me use u, since we've come from high school and we know u is used for initial velocity and v for final velocity. Okay, so when a projectile point here, what is happening is it is turning. And the only way something can turn is when it stops. So at the maximum point here, it is going to what? Stop moving for a moment. And so therefore now that is the final velocity in the y is what? 0. That is because it is no longer rising, it is no longer going up. You need to know that velocity in a projectile does not change, it is always constant. The same velocity in the thing is the same velocity that is going to have at this point, and it's the same velocity that is going to have at this point. Velocity is always constant. Please know that from this time. Now the distance from where thing up to where it ends is called the horizontal range, and then from the mid there to the maximum, that's called the maximum height. Okay, like that. And then the time it takes a projectile to move from where you threw it to the very point where it is going to reach the bottom is called the time of, or total time of flight. So when you're talking about flight is simply the journey, or more the distance something is going to take to move from one point to the next point that is going to reach. So these are some terms that you need to know. Now, the distance, please, horizontal means going like this, vertical going up. Never say horizontally upward, that's wrong. Horizontal is up. All right, so if you want to get the maximum horizontal range, the angle that you need is 5 degrees. When you throw something at 45 degrees, you are going to gain the maximum horizontal range. For example, when you throw something, the projectile will go like this when the angle that you've used is 80 degrees. When you use the 60 degrees, the projectile is more up and then come down. This is 60 degrees. But when you use 45 degrees, what is going to happen is the projectile is going to go like that and then reach that point. So when you want to get the mass down, always use what? 45 degrees. Now, which apply when it comes to this topic. I'm not going to write them. We are going to get them so that to not be an issue of mastering, but no. So we are saying we have got the angle first, and you throw this projectile, and then you have got the initial speed, which we are calling as u. And then we are saying at the very point, velocity in the y is 0. Now from the equations of motion, the first equation of motion that we are going to use is v is equal to u plus at. Now in this case we are going to talk about the final velocity in the y. So I'm interested in motion just up to the max. This v is representing final velocity, u is initial velocity. So the final velocity, since we're talking about vertical motion, the final velocity you can see in the y is what? 0. And then the initial velocity in the y, how do you a projectile? It is the same u which you have. Okay. And then remember, this is in the y. Whenever you're talking about in the y, it's same velocity sin theta. In the x, it is the same velocity cos theta. And then now, because this is something that has been thrown up, the acceleration that applies for something that has been thrown, subjected to uh, air and everything else, is g. So that is acceleration due to gravity, and then multiplied by t. Therefore, I'm going to now even put this. When you throw something up, it is going against gravity because gravity is going downwards. Therefore, the g we are going to use here will not be positive g but negative g. Why? Because we are going against gravity. And then t. So I'm going to take this term and take it the other side. That gives us gt being equal to, instead of me using u, let me just say this is v for convenience's sake. So it's going to be v sine theta. So for me to remain with t equal to v sine theta divided by g. To move from this point to the maximum point. Now this projectile is metrical. The time taken to move from this point to the maximum is the same time taken to move from the maximum to the down. So if you want to find the total time of light, just this formula which you have, just multiply it by 2. That would be 2 v sine theta over g. So if a question came, to find the total time of light, you just need to know the initial velocity and also the angle of what? The projectile. This is the formula for total time of flight. Is anyone left behind? All right. On the 2. Okay. So we are saying this time is the time taken for the projectile to move from this point to the maximum point. But this projectile is, if you cut it on the mid, what is happening this side is the same as what is happening this side. So if you know the time from here to the maximum, then to find the time direct from here to the maximum and then down here, just multiply the time from here to the maximum by 2. Is that okay? Is that fine or the oh, I said instead of you just using u, let me change, I use v. So I changed, instead I put v there to represent initial velocity. So it's just a representation, it doesn't change anything. As long as you know that the v which is in this equation is the initial velocity. Now we can go to another equation. Yes. Yes, the one multiplied by 2 is for the total time of flight. The one without a 2 is just the time from the start of the projectile to the maximum point. Okay. So another equation that we're going to write, just equations of motion which you already know. 2gh is equal to v squared minus u squared. Do you remember this equation? Who has remembered the equation? We can't remember it. So this is one of the equations of motion. 2gh is equal to v squared minus u squared. Maybe you knew